Hello my dear students. So welcome to today's lesson. Now this is the next chapter where I'm going to continue with extra questions. In the previous chapter we discussed the questions given in your textbook. So this is related to properties of matter. As you can remember, we started off by discussing what is matter, then the discontinuous nature or particulate nature of matter, the three physical states, solids, liquids and gases, and how particles are arranged in them and their properties. Thereafter, we discussed the physical properties of matter, and based on that, we were able to divide elements and compounds under pure substances, and you all know the non-pure substances are mixtures, and thereafter, the elements and compounds were classified as metals and non-metals. And finally, we discussed the uses of different matter in our daily life. So you're familiar with the lesson, and now also I want you all to answer these questions by yourself first and then compare your answer with my discussion. So extra question 1. Underline the most suitable answer. Similar to what we did before, you either select then underline the correct answer or the most suitable answer. So if there's only one correct answer, that's one. Otherwise, there can be more than one correct answers, but out of those, one would be more suitable. So you have to select that answer. The first one, not an example of matter. So this is not an example of matter. What is matter? Anything that has a mass and occupies space is matter. It can be a solid, liquid or a gas. So air is gaseous state, but it has a mass and it occupies space. So it is matter. Then light. Light is a form of energy. Now energy does not have a mass. It does not occupy space. So that is how we classify non-living components as matter and energy. Light is a form of energy. Then water. Water is also matter. Liquid state, and it has a mass and it has a volume. It occupies space. Then solution. Any solution. Solution can be a mixture of any matter. So that is also an example of matter. So the question is not an example of matter. Air, water and solution, they are all matter. Only light is not matter. It is not an example of matter. Then the second one, a brown colored gas. So you have to check whether it is a gas and you have to see whether the color is brown. Now, if you remember, students, we have looked at a gas that is brown in color. Can you remember that? For the particulate nature of gases. Nitrogen dioxide gas, a brown colored gas. In addition to that, iodine is a solid substance that is also brown in color. It can be dissolved and formed into a solution, but there it is not a gas. Although it's brown in color, it's not a gas. So the first one, carbon dioxide. Carbon dioxide is there in our atmosphere. It is colorless. Otherwise, you will see carbon dioxide gas. So it is a colorless gas. Then sulfur dioxide. That is also a colorless gas. Although sulfur is yellow in color, sulfur dioxide is a colorless gas. Then nitrogen dioxide, yes, that is a brown colored gas. Nitrogen dioxide is a gas and it is brown in color. Then potassium permanganate. Potassium permanganate is a solid crystals. You have seen it. It looks almost blackish in color, very shiny crystals, but when you dissolve it, you get a purple color solution. So that is a solid and not brown color. So a brown colored gas is nitrogen dioxide. So that is nitrogen dioxide. So like I told you all before, students, when you answer the questions, you have to look at all the answers and select the most suitable one. So that we have done the first two, we'll move on to the next question. Question number 3. A metallic element that exists as a liquid at room temperature. So here again, you have to look at two properties. What are they? It has to be metallic and also it should be a liquid. you can remember what that is. Mercury, that is used in thermometers, it is a metallic element and also it is a liquid. Sodium, sodium you have seen. Sodium is a solid metal. You have seen that. Then aluminium you have seen. A silvery shiny metal. You have aluminium foil at homes. You might have seen in different places. Aluminium is a metal. Then lead. Lead is also a solid metal. Then mercury is a metal and it is a liquid at room temperature. So all four, sodium, aluminium, lead and mercury, all of them are metals. Only mercury is a liquid at room temperature. So that is the answer. Then the fourth question. Elements present in copper sulfate. Now copper sulfate. From the name you can understand copper is there. You can relate it and remember, that's easy, copper sulfate. So when we say sulfate, sulfur should be there. Another element is there. It is oxygen. So copper, sulfur and oxygen are present in copper sulfate. So the answers copper, sulfur, oxygen. First one is correct. Copper, sulfur, oxygen is missing. Then copper, sulfur, phosphorus. Phosphorus is not there in copper sulfate. Copper, oxygen, they are there but sulfur is missing. So the correct answer is copper, sulfur and oxygen. The three elements make up copper sulfate. So we have a table in your textbook. You can remember the compounds with their elements that make up the compound. So you have to remember those elements relevant to each compound. So with that, students, we'll move on to the next question. Fifth one. A non-metal that conducts electricity. So here again you have to see it should be a non-metal that conducts electricity. So two things that are important. Usually metals conduct electricity, that you know. Non-metals do not conduct electricity. But there is an exception. Carbon, graphite conducts electricity well. So graphite is a non-metal that conducts electricity. Let's look at the answers. Bromine. Bromine is a liquid non-metal. It doesn't conduct electricity. Sulfur, again a solid non-metal. It doesn't conduct electricity. Carbon, yes. Carbon is a non-metal, a solid, and it conducts electricity in the form of graphite. Then nitrogen is a non-metal, is a gaseous form. It does not conduct electricity. So it's only carbon that conducts electricity. So carbon. Then the sixth one. A non-metal that exists as a liquid at room temperature. So here again you have to check whether it's a non-metal and whether it exists as a liquid at room temperature. You can remember, students, when we discussed that table in your textbook, most of the metals were solids. Sodium, magnesium, aluminium, iron, zinc, copper, all those are metals. Only mercury was a liquid. We did not come across any gases under metals. But when we discussed the non-metals, you were able to see there were solids, liquid, and there were gases. So here you have to look for a non-metal that exists as a liquid at room temperature. First one, chlorine. Is it a metal or a non-metal? Chlorine is a non-metal, but it is a gas. So here you can remember chlorine, non-metal, but it is a gas. Now bromine, that is also a non-metal, but bromine is a liquid. Bromine is a liquid. Then how about iodine? That is also a non-metal, but iodine is a solid. Then fluorine, again it is a non-metal, but it is a gas. So all four of them are non-metals. Chlorine and fluorine, they are gases. Iodine is a solid. So we need a non-metal that is a liquid. That is bromine. So the answer is bromine, a non-metal that exists as a liquid at room temperature. So students, when you all do questions like this, you have to look at the different answers. You have to look at all the answers and you should understand why they cannot be the correct answer. Even in the previous one, a non-metal that conducts electricity. So you have to check whether it's a non-metal and whether it conducts electricity. So combination of characteristics or properties, that's what's important here. I'm sure up to now you were able to answer the questions correctly. So with that, I'll move on to the next question. Question number 7. So the question is boiling point of pure water. What is boiling point? The temperature at which the liquid turns into a gas without changing in temperature while heat is being provided and under standard atmospheric pressure. That's very important. So you have to remember students, boiling point, melting point and density. Those are 3 properties that have definite values for pure substances. So for example, if you take water, water boils at 100 degrees Celsius under standard atmospheric pressure. But if there are substances dissolved in it, then of course the boiling point changes. So then it is not a pure substance anymore. You all can remember that. So boiling point of pure water is 0 degrees Celsius. What is that? That is the melting point of pure ice. So this is melting point of ice. Point of ice. Then 100 degrees Celsius, boiling point of pure water. 70 degrees Celsius, that is a different temperature. It can be a boiling point of a different liquid but not pure water. Then 4 degrees Celsius, that is also a different temperature. So out of these, the correct answer is 100 degrees Celsius. That is the boiling point of pure water. Very important. It's pure water. So a fixed value for boiling point. Then the 8th one, a property of a non-metal. So the term non-metal, you have to check. We look at the properties. Lustrous nature. What is luster? The shine of metals. When you scrape it with sandpaper, the shine that is given out. Now magnesium, when it is in the lab, when you store it for some time, it's not shiny. But when you take the magnesium strip, you scrape it with sandpaper, then you see the shine. But there are some metals. Now say aluminium, even mercury. Although it's a liquid, you can see the shine. Now sodium, when you take it out, you have it in the lab. Where you store it inside kerosene, you take it out. When you cut it, the cut surface will be shiny. But after some time, it tarnishes. So the shine can tarnish, but once you clean it or freshly cut surface will be shiny. That nature is what we call as lustrous nature. Then second one, sonorous sound. How do we identify sonorous sound? It is the ringing sound. So you need to have a certain thickness for the metal, and when you hit it with another object or when you drop it on the floor, if you hear a continuous ringing sound, that sound is what we call as sonorous sound. So you all know students, mostly metals, so lustrous nature and sonorous sound is usually seen in metals. Then if you take the next one, malleability. What is malleability? The ability to be hammered into sheets without breaking into pieces. So that again is usually seen in metals. That also you can remember students, we discussed before, not all metals are not malleable or ductile. But usually they show that property. They can be hammered into sheets. So there again we discussed even mercury is a liquid. So there you can't hammer it into a sheet, it's already a liquid. So but most of the metals are malleable. So lustrous nature, sonorous sound, malleability, all are properties shown by metals. These are properties shown by metals. Then the last one, brittleness. when applied with a force or when you hit them with the force, they break into pieces. That is what we call as brittleness. Usually, non-metals are brittle. Now, you can remember carbon, graphite, then even sulfur, you get it as, powder. So, mostly non-metals are brittle in nature. So, that is the answer. A property of a non-metal is brittleness, because all the other three properties, luster, sonorous sound and malleability, those are usually properties of metals. I am sure you can remember that, student. So, with that, we'll move on to the next question. Question number 9. Matter. Now, when we say matter, what is matter? Anything that has a mass and that occupies space is matter. It can be a solid, liquid or gas. Those are the physical states of matter, and they have many other properties as well. And all matter are discontinuous in nature, or what we say as particulate in nature. Now, matter has a mass. That is correct, no? Matter has a mass. Then matter occupies space. That is also correct. Then matter has a mass and occupies space. That is also correct. Now, this is where you need to select the most suitable answer. We look at the fourth one. Doesn't have a mass but occupies space. That is of course wrong. It does have a mass. So, this is incorrect. Now, all three, the first three are correct. But out of those, the third one is more suitable. Why? Because it has a mass and it occupies space. So, we need to select the third answer. Then, the 10th one. Particles are strongly bound to each other in what? If you take the solids, solid, liquid and gases. Now, solids, the particles are very tightly packed and they are very strongly bound. Whereas liquids, the particles are somewhat far apart. So, they are not very tightly bound. Gases, the particles are involved in random movement. They are very far away from each other. They are involved in free random movement, and there is no interaction or very less interaction between the particles. So, particles are strongly bound to each other in where? In solid. So, solids, liquid, gases, in all of the above. So, out of the 4 answers, solids is the correct answer. Particles are strongly bound to each other in solid. I am sure you can remember that. Now, again and again, I am drawing these structures. So, you recall what it is and you will always remember the particulate nature and how particles are arranged in solid, liquid and gases, and how that arrangement of particles is related to their properties. That's how you have to understand. So, with that, we'll go on to the next question. Question number 11. So, there the question is a pair of elements. So, 2 substances are given. You have to check whether they are elements or not. So, they should be pure substances, and under that they have to be elements, not compounds, not mixtures. So, if we look at the answers, first one, water. When you normally say water, we can consider any water. Sea water, tap water, bottled water, all these are mixtures. They are not pure substances. Only if they say pure water or distilled water, that is there in the lab, that means it's pure water. So, water, mixture. Air, I told you all this. Now, air is in the atmosphere around us. There is nitrogen, there is oxygen, there is carbon dioxide, water vapor and other gases. So, it is a mixture. So, both of these are mixtures or non-pure substances. Then sugar and salt. Sugar, it is a compound. Salt is also a compound. So, these are both compounds, not elements. Compounds. Then sulfur and iron. Yes, sulfur is a non-metal, iron is a metal, but both of them are elements. So, they are elements. Then the fourth one, nitrogen and glucose. What are they? Nitrogen is an element, it is a gas, whereas glucose is a compound. So, nitrogen and glucose, element and compound. So, water and air, they are mixtures, sugar and salt, they are compounds, sulfur and iron, both of them are elements, so that's the correct answer. But nitrogen and glucose, nitrogen is an element, glucose is a compound. Is that okay, students? So then we look at the 12th question. A pair of compounds. Now here you need to select the compound. First one, salt and water. Now water again is a compound. Now we don't know whether it's pure water or whether it's another sample of water where it can become a mixture, but usually we can consider it as compound as well. We look at the answers and these are. Then zinc and copper. Zinc and copper, they are both metals, so they are both elements. This is very sure. Zinc and copper, they are both elements. Then water and oxygen. Here again you can see water, it can be a compound or a mixture, but we can take it as a compound. But oxygen, you know for sure, it's an element. So here I will write it as compound and element. So then carbon dioxide and carbon. They are also, you're sure, carbon dioxide is a compound and carbon is an element. So, carbon dioxide is a compound and element. So, then we are only left with salt and water. So, here we have to assume that water is the pure compound. Only the compound is considered here. So, salt and water both are compounds. So, we have to select the first answer. Salt and water, they are both compounds. So, in that case, in the previous question also, students, now water and air, they have asked for a pair of elements. So, anyway, that's not the answer. So, water and air, I took water as a mixture considering the fact that it can have other substances depending on the sample. But since it was not mentioned as pure water, I took it as a mixture. But there are also, you can consider this as a compound. So that is also something you have to remember. Now here also water is a compound. It can be it is a compound, that is pure water is a compound. With that, if there are substances mixed, then it becomes a mixture. So, we can consider that as a note. So, you can see water. So, pure water is a compound that is made up of hydrogen and oxygen, you can remember that. But other samples of water, say drinking water, then bottled water, even sea water, all these are mixtures or what we call as non-pure substances. You are very much clear with these concepts, students, because when we measured the density, we use different samples of water. We use distilled water. We measure it many times. The volume is the same because we use that particular bottle, but the mass was also same. So from that we were able to conclude pure water has a fixed density. So you can understand that, you can remember that activity. Pure water has a fixed density, whereas other samples, different water from different places, because there are substances dissolved in it, the density is different. So that means those are all mixtures or non-pure substances. So that is why when I discussed this first question, I first took water as a mixture, both water and air, but there are also, since it is not specified what water that is, we can also consider it as compound. But either way, in both these, you can see here, of course, a pair of elements is sulfur and iron, so there's no problem. But here, a pair of compounds out of all the answers, salt and water is the most suitable answer. So here, water needs to be considered as a compound. So we need to consider it as pure water. So normally when they say water, we will take it as pure water. But if it is some other water like seawater, rainwater, bottled water, then you all know it is a mixture. I'm sure you all can understand that, student. So with that, I'll move on to the next question. Question number 30. Density means the mass of unit volume of a substance. That you all know. Density means the mass of unit volume of a substance. So here, if we look at the answers, first one, volume of a substance, it is the volume. Then mass of a substance, no, that is also different. Both factors have to be connected for density. Mass of a unit volume of a substance, that is the correct answer. Then the fourth one, arrangement of particles in matter, that actually gives rise to the three states of matter: solids, liquids and gases. From the particulate nature or the discontinuous nature, the way the particles are arranged gives rise to the three states. So out of all the four answers, density means the mass of a unit volume of substance. That is the correct answer. That is the definition for density. Then the 14th one, the property or properties that have a fixed value for a pure substance. What are the properties? You can remember melting point, the temperature at which a solid becomes a liquid. At standard atmospheric pressure, there again, even though you provide heat, the temperature doesn't change, and that will be a fixed value for a pure substance. That is melting point. Then you have boiling point, the temperature at which a liquid becomes a gas. Again, while providing heat, the temperature doesn't change and the state change takes place. And at standard atmospheric pressure, we normally say the boiling point, and that is also a fixed value for pure substances. Then density, a mass of a unit volume of substance. That is also a fixed value for pure substances. So melting point, boiling point and density are all fixed values for pure substances. So from that you can identify the purity of the substance. So the property or properties that have a fixed value for a pure substance, that's very important. Fixed value for a pure substance. Now here you can see melting point, that has a fixed value, boiling point and density. So all three answers are correct. That is why we have the last answer, all of the above. All three are correct. So we select the fourth one, all of the above. Property or properties that have a fixed value for a pure substance, all three: melting point, boiling point and density. I am sure you all also answered these correctly. So with that, students, we'll move on to the next slide. Question number 50. This is the last question under multiple choice type questions. A pair of non-metals. So you all are familiar with metals and non-metals. We'll look at the answers. Copper and aluminium. They are both metals. Both are metals. Then sulfur and phosphorus. Both of them are non-metals. Whereas the third one, copper and carbon. Copper is a metal, carbon is a non-metal. So here of course metal and non-metal. Then the fourth one, aluminium and zinc. Again both of them are metals. So the most suitable answer or the correct answer is sulfur and phosphorus. Out of all four, copper and aluminium both are metals. Sulfur and phosphorus both are non-metals. So that's why that's the correct answer. Then copper and carbon. Copper is a metal, carbon is a non-metal, and aluminium and zinc both are metals. So up to here students. I'm sure you all understood all the questions and you all also answered them correctly. Now I'm going to move on to the second extra question where we have to write the answers. I'll move on to the next slide. So extra question 2. First one, what is the difference between matter and energy? What is the difference between matter and energy? Matter is anything that occupies space and has a mass. So anything that does not occupy space and does not have a mass is energy. So here we need to write the difference. So we have to say matter has a mass and occupies space, but energy does not have a mass and it does not occupy space. So that is what we need to say there. Matter has a mass and occupies space, but energy does not have a mass and does not occupy space. So that is the answer to the first question. What is the difference between matter and energy? Matter has a mass and occupies space, but energy does not have a mass and does not occupy space. Then the second one. What is meant by discontinuous nature of matter? Discontinuous nature or particulate nature of matter. What is that? Matter is made up of particles that have space among them. Or you can say matter is an arrangement of particles with space among them. That is what you have to write here. So we can write the answer as matter exists as a collection of particles with spaces amongst them. So that is what we say as discontinuous nature of matter or particulate nature of matter. Then we have the third part. Write another term for discontinuous nature of matter. What is another term? That is particulate nature of matter. So here we can say particulate nature of matter. Then the fourth part. What are the three physical states of matter? What are they? Based on how the particles are arranged, there are the solids, liquids and gases. So solids, liquids and gases. or you can write it as solid, liquid and gas. So the answers, what is meant by discontinuous nature of matter? Matter exists as a collection of particles with spaces amongst them. And another name for discontinuous nature of matter, particulate nature of matter. And the three physical states of matter, solid, liquid and gas. So those are the answers for these questions, students. With that, we'll move on to the next question. Extra question 3. So here, of course, they have given a diagram. You can see in this, there is the beaker and there is blue ink inside. And there, what do? They immerse a strip of paper. That is the second part of the activity. And in the third step, you can see the part of the paper is colored in blue color. So what happens here? When you insert the piece of paper, paper is solid, it's matter, it's made up of particles. Then blue ink is a liquid. Again, it is matter, it is made up of particles. So what happens there? The liquid particles of blue ink move through the spaces present in the particles of paper. In paper, paper is made up of particles with spaces in between, and between those spaces, the blue ink particles can be moved up or they'll be absorbed up. So that is why, or they are sucked up, you can say. They move up. So that's why part of the paper becomes blue in color. So this is again a simple activity that can be used to denote that ink or liquid is made up of particles as well as paper, that is a solid, that is made up of particles. So then the questions. What is the observation when a strip of paper is dipped into a beaker containing blue ink? So then here, of course, we'll read all the questions, students. Then in the next slide, we'll answer the questions. So first one, like I read, what is the observation when a strip of paper is dipped into a beaker containing blue ink? That is what I explained. Then what is the reason for the above observation? That also I explained, the particulate nature. Then what can you conclude from the above observation? Yes. And fourth one, an item made up of gold is damaged if it comes in contact with mercury. Explain this observation using the particulate nature of matter. So those are the questions related to this diagram. We will answer them one by one. So again, the same diagram is given to you. I explained the activity, the observation and the reason. So the first question. What is the observation when a strip of paper is dipped into a beaker containing blue ink? The blue ink will be, or we can say the paper will become colored. So here you can say the color will be soaked up. The paper will be soaked in blue color. So that is what you can say. So here you can say the strip of paper will get soaked in blue color. Or you can say the colored ink rises up along the paper. So that is also okay. You can either say the strip of paper will get soaked in blue color or the colored ink rises up along the paper. Both are same. So that is what you see, little by little it will get soaked and it will become colored. Then the second question, what is the reason for the above observation? So what is the reason for the above observation? Strip of paper is made up of particles or it is discontinuous. Blue ink is also particulate in nature. So the ink particles rise up through between the spaces of the paper particles. So that is what you have to say. The strip of paper of paper is made of particles with spaces among them. The blue ink is made of particles. When the paper is in contact with the ink, the ink particles rise up through the spaces between the paper particles. So that is the reason. The strip of paper is made of particles with spaces among them. The blue ink is made of particles. When the paper is in contact with the ink particles rise up through the spaces between the paper particles. That is why the strip of paper gets soaked in blue ink. So both of these reasons, because both of them are particulate in nature, you get this observation. So then we'll answer the next part of the question. Again the same diagram. Third question. What can you conclude from the above observation? What can you conclude? Ink is discontinuous in nature and the color, the paper, piece of paper, strip of paper is also discontinuous in nature. So we can say both the ink, that is a liquid, and strip of paper that is a solid are discontinuous in nature. Or you can say this is an example of discontinuous nature. So then the next question. So what can you conclude from the above observation? Both the ink, that is a liquid, and strip of paper, that is a solid, are discontinuous in nature, or you can say particulate in nature. Then the fourth question. An item made of gold is damaged when it is in contact with mercury. So you all know gold is a metal. It is used to make jewelry. So there the gold can come in contact with mercury and then the gold jewelry gets damaged. They want you to explain this observation using the particulate nature of matter. So what can you say there? Now gold is a metal, it is a matter. So that is made up of gold particles with spaces among them. Then mercury is also a metal, a liquid metal, and it is matter. So that is also made up of mercury particles. So when gold comes in contact with mercury particles, what happens is the mercury particles move through the spaces of gold particles. Because of that, the gold jewelry gets damaged. The mercury particles are stuck to the gold jewelry, and because of that, the gold jewelry gets damaged. That is what you have to explain here. So we can say both gold and mercury are metals. Gold is a solid matter and mercury is a liquid matter. They are both discontinuous in nature. That is why when gold is in contact with mercury, the mercury particles move through the spaces between gold particles and the gold jewelry gets damaged. So here students, the important part is you have to say they are either particulate in nature or discontinuous in nature. If we look at the answer, you can see an item made of gold is damaged when it is in contact with mercury. Explain this observation using the particulate nature of matter. Both gold and mercury are metals. That of course if you want you can avoid. You don't have to write it. It is not a must. But that is to just to give you more information. Gold is a solid matter and mercury is a liquid matter. They are both discontinuous in nature. That is why when gold is in contact with mercury, the mercury particles, you can say mercury particles, move through the spaces between gold particles and the gold jewelry gets damaged. So that is what happens here. I'm sure you all can understand. So that was the question, the different parts of the question. Now I am going to move on to the next question. That is extra question 4. Consider the activity given below. So look at the activity. Here we have a beaker with water, a piece of condis. You know condis is made up of crystals. Here it's a piece of condis. So it will look like a black color solid, shiny solid. It is a compound. Then what happens there? When you put it into water, you can see the condis dissolving in water. Although the solid looks black, when it dissolves, you can remember it turns purplish in color. The condis solution, that is potassium permanganate solution. Condis is potassium permanganate. That is purple in color. So here piece of condis is potassium permanganate. Potassium permanganate. So the first question, the piece of condis dissolves in water and a purple color solution is obtained. What is the reason? What is the reason? The condis particles are able to move amongst the water particles. So that is why they mix and form a purple color solution. That is the reason you have to write here. The condis particles move between the spaces between water particles. Therefore, condense dissolves in water and forms the purple color solution. So that is the reason, because the particles of condense are able to move through the particles of water. Then the next one can say, what can you conclude from the above activity? What can you conclude? Both water and condense are particulate in nature. That is what you can conclude. So both water, again it is a liquid, and condense, it is a solid, are particulate in nature. That is what you can conclude from this. Both water, that is a liquid, and condense, it is a solid, are particulate in nature. So this is something you have to understand. So here, this is the activity. You see the condense dissolving and forming the purple color solution. The questions are somewhat tricky. You can see here they have asked, what is the reason? So there you have to talk about the spaces and the particles moving in between them. So because of that, we can conclude and say both condense and water are particulate in nature or discontinuous in nature. So this is an example or proof of discontinuous nature of matter. I am sure you all were also able to answer this correctly. So with that, students, I am going to move on to the next question. Extra question 5. So there is a diagram given to you. You can see this is a brown colored gas in a gas jar, and there is air there. So that is another gas jar. When you invert the gas jar with air on top of the gas jar with the brown colored gas, it will be usually nitrogen dioxide gas. You can see the spreading of gas there. You can see the color spreading. So again, the mixing of two gases, two gaseous substances. One is air, one is nitrogen dioxide. How is that possible? Because nitrogen dioxide is made up of particles, air is made up of particles, it's a mixture, it is made up of particles. The nitrogen dioxide particles can move through the spaces of air particles, or vice versa. Air particles can move through the spaces of nitrogen dioxide particles. So therefore, both the gases mix and the color spreads, and also you can see here it is more darker in color. Once it is spread throughout the two gas jars, the color becomes slightly lighter because there is air also mixed with nitrogen dioxide now. So from that, we can say gases are discontinuous in nature. That is the conclusion you can get. So if we look at the question, consider the following instance. It is observed that after some time, the brown colored nitrogen dioxide gas mixes with colorless air. So what is the reason for this observation? What I explained. The brown colored nitrogen dioxide gas particles move between the spaces present between particles of air. So because both of them are particulate in nature. So here this is what we have to write. We can say the nitrogen dioxide gas particles move between the spaces of air particles. I have written a very short answer here, students, with the limited space. The nitrogen dioxide gas particles move between the spaces of air particles. Or we can say spaces. I will say spaces present between air particles. That is a more better answer, because air is made up of air particles, nitrogen dioxide is made up of nitrogen dioxide particles. There are spaces between both particles. So one nitrogen dioxide can move between air particles, and air particles can move between nitrogen dioxide particles. So this is a short answer. If you are to give a long one, you can explain everything and write. That is also okay. Then the second part of the question. What can you conclude from the above observation? Air is discontinuous in nature. Nitrogen dioxide is discontinuous in nature. Or we can say both air and nitrogen dioxide are discontinuous in nature. Or this is an example of discontinuous nature of gases. Then the third part of the question. Write 2 examples for the discontinuous nature of gases from daily life. From daily life, what can you say? The fragrance. When you spray a perfume, when you spray an air freshener, or if you burn an incense stick, you get the smell spreading over a large area. It doesn't have to be a nice fragrance, even a bad odor. If there is something rotten somewhere, you get that bad smell. So there, the smell spreads through air because air is made up of particles. The smell again is chemical particles. The particles of the smell, whether it's fragrance or a bad odor, it spreads through air. That is why you are able to see that. Then fumes or smoke. When you burn firewood, when you burn some things, the smoke spreading through air, that is visible. Why is that? Because smoke is particles, air is particles. You see them moving through air. So like that, you can write any 2 examples. So write 2 examples for the discontinuous nature of gases. Now here, both have to be gases. So that is what I am going to write. 1. The fragrance of perfume spreads through air. Then you can say smoke particles spread through air. Write 2 examples for the discontinuous nature of gases from daily life. So the fragrance of perfume spreads through air, and also smoke particles spreads through air. So these are all examples. You can write any other example as well. Instead of the fragrance of perfume, you can say fragrance of air freshener, fragrance from incense sticks. Anything can be written there. Then also smoke. You can see the smoke particles. You can see colored dust when it is spread through air. You can see the color spreading like in nitrogen dioxide. There is this festival where they spray colors. So you see that spreading through air. Those are all examples that you can write here. Discontinuous nature of gases. So I'm sure students, you were able to answer all these questions correctly. So this is the 5th question. With that, I'm going to end this chapter, and in the next chapter also, I will discuss some more extra questions with you.